Alright, here is a theorem that says if a line is drawn from the center of a circle perpendicular to the chord, then it bisects the chord. Right. So if you look at this information or look at this statement, it is divided into two parts. The if part, if a line is drawn from the center of a circle perpendicular to a chord. Right? Then the second part say then it bisects the chord. So the first part, right, it is the information that is given. So what is given according to this? This tells us that there is what? There is a line. Then this line is drawn from the center, so there is a center. Right? So if there is a center, obviously, then there is a circle. Right? And then it says the line is perpendicular to the chord. So this line is perpendicular to the chord. Right? This is the part, this is the if part. So let's try to draw this circle and put a center here. And then from there, chord, and then let's put a line that will join the center and the chord. And they're saying these two are perpendicular. Alright. So this is a circle with a center, and then the line from that join the center and the chord, and then the center and the line and the chord, they meet at 90 degrees, meaning the line is perpendicular to the chord. Right. Now let's look at the then part. Then it bisects the chord. So it says then it bisects the chord. So it says this line, it means it bisects the chord. Right. So this is what we want to prove. We want to prove that this line bisects the chord. So we want to prove that this line bisects the chord. By bisecting, we mean it cuts it into two equal halves. So let's say here we've got O, here we've got B, here M, then let's say it's M1, this is M2, and then this is B. So A, O, M, B. Then we've got M1 and M2. Remember, they said these two lines are perpendicular, so M1 and M2, they are both equals to 90 degrees. Right. So the given information will be, we are given by the if part, we're given circle with center. Let's say our center is O, right? Where OM is perpendicular to AB. This is what is given, right? And then we are required to prove that it bisects the chord, that this line bisects the chord. So it cuts the chord into two equal halves. So in other words, you want to prove that AM, we are required to prove that AM is equals to MB. Right. But now can we prove that AM is equal to MP with this information as it is? No, we cannot. But what we can do some construction. Right, so we'll need construction. Our construction is simply join AO and BO. Right. And remember, when we're doing that, we're not just drawing any line. We are drawing lines that we were joining these 2 points and these 2 points so that they can help us to achieve our goal, which is to prove that AM is equal to MP. So I'm not just drawing any line. but it's a line that is helping us to prove that AM is equal to MP. Now, what have I created here? I've created three triangles: AOB, AOM, BMO. But I'm interested in AOM and BOM. Why? Because if I can prove that these two triangles are congruent, then it will mean that I've proven that this one is equal to this one. So let's go. So it means for you to successfully prove this theorem, you need to understand congruence of triangles, right? So proof, we're going to say in triangle AOM and triangle BOM, these two triangles, right? This one and this one. If I look at these two triangles, I can say AO is equals to BO. Why? Because these are radii. Right, this is the radius and this is the radius. So this is equals to this. Because the radius of a circle will be the same, right? So this one and this one are equal. Even if I can draw another one here, it will be the same size as these two. So radii of a circle are the same, right? Now, if I'm looking at triangle AOM, I can see that OM, this side, is a common side, right? It's common, so it is equal to itself, right? So OM is equal to OM, right? Now, the last one, I can say M2 of this triangle is equal to M1. Why am I saying this? I am saying this because I am given that OM is perpendicular to AB. That's what they're saying. Say the line from center perpendicular to the chord. So in other words, this is given, right? So now with these three conditions, right, I can conclude that. So I can say therefore triangle AOM is congruent, meaning it is equal in all respects. All the sides are equal, all the corresponding sides are equal, all the corresponding angles are equal to triangle BOM. Right. So if these two triangles are congruent, it means this side equals to this side equals to this side, and then this side is equals to this side. That's what I'm looking for. Even the angles, this angle is equals to this one, and this one is equals to this one. But I'm interested in AM and MP. So I can conclude and say, therefore, AM is equals to MP because these two triangles are congruent. So we have proven that AM is equals to MP.